Okay, in this video we're going to look at solving exponential equations and inequalities. Okay, so this is really best demonstrated with some examples. Okay, so what we've got here is we've got 4 to the power of x equals 256, and we're going to work out what x is equal to. Okay, so the key here is to make bases the same. Okay, so 256 can actually be written with a base 4. So we can say that 4 to the power x, okay, 256 is actually 4 to the power of 4. Okay. Once we've got that, and our bases are the same, we're allowed to equate our powers, or our index. So we can say that x is equal to 4. We're actually done. Okay. Similarly, with this one, okay, 81 okay, is a power of 3. So we can say that 3 to the x take 1 equals 3. And again, 81 is actually 3 to the power of 4. So in this case, now we're allowed to equate our powers. So x take 1 equals 4, so x will equal 5. Okay. Again, similar with this one, we've got to be a little bit careful here. Okay, so with this one, we've got our 5 to the 2x take 4. Now 25 is obviously 5 squared to the 2 take x. Okay, so from our index laws, we multiply these. So we say we've got 5 to the 2x take 4 equaling 5 to the 4 take 2x. Okay, so we need to be a little bit careful there. Now, but again, now that our we've equated our, we've got the same base now, we've made them the same, we can equate their indices. So we've got 2x take 4, then 4 minus 2x. So now add my 2x on. So I've got 4x. I'm going to add on 4 this way as well, which is going to give me 8. So x is going to equal 2. Okay, so the main idea here is we've got to get our bases on both sides the same, and then that will allow us to equate our indices. Okay, now I'm going to show you a couple a little bit harder. Okay, which are these ones here. Okay, now you might look at this and go, okay, well, 9 to the power of x equals 12 times 3 to the power of x, take 27. Okay, that one looks a fair bit different, but we can make it work. Okay, so what we want to be doing here, okay, with this first one, is realizing here, that's really, we can write that, think of this as 3 to the x squared. Okay, we're allowed to have it like that, which means then we've got 12 times 3 to the x take 27. Now it might be tempting to do something here with this 27, but trust me, we don't want to do that. Okay, because we've got this thing here, this 3 to the x squared. Now there's these other things here, which is 3 to the x, and then something by itself. And what we do here, and this is a really neat little thing, is we say let a equal 3 to the x. Okay, so in here, everywhere we've got 3 to the x, we're going to put an a. So this means now that we've got a squared equals 12a minus 27. It doesn't take a lot of work to realize that we can move this across and say we've got a squared take 12a plus 27. Right. Okay, and that's equaling 0. Now hang on, all of a sudden now we've got a quadratic, okay, that we can solve. Now don't worry about the quadratics here, they're not going to be awful ones. Okay, so we need to look here and go, okay, I've got factors of 27. Okay, this is positive and that's negative, so they're both got to be negative, and I've got to get to a total of 12. So I can see there that I'm going to be a take 9 and a take 3. Okay, negative 9 take 3 gives us negative 12, and negative 9 times negative 3 gives us positive 27. Now we null factor law that and say that a equals 9 and a equals 3. Because either this or this equals 0. Now at this stage, what we need to do is we need to actually substitute back in a. So we say 3 to the x equals 9 and 3 to the x equals 3. Now if we look at this 9 first, we know that 9 is 3 squared. Therefore, I can now equate these values and say x is equal to 2. Or over here, 3 is really 3 to the power 1. So I can say that x is also equal to 1. Okay, so from starting out there, we've got two solutions to this equation. That's x equals 2 or x equals 1. Okay, similarly, we're going to be able to do something similar here. Okay, because we've got 3 to the 2x, but we can really think of that as 3 to the x squared. We're really undoing one of our index laws, because one of our index laws says we can go from this to this. So we're really reversing it. Same idea here. We're reversing our process. Okay, and then we can say we've got 3 times 3 to the x plus 10. Okay, well we can say let a equal 3 to the x again. So I'm going to have a squared equals 3 times a, okay, or just call that 3a, can't we? Plus 10, okay. Take both these away over this side. A squared, take 3a, okay, take 10 equals 0, okay. This is negative and this is negative, so that means one's positive, one's negative, and the positive one, sorry, the bigger one is more negative. Okay, factors are 10. Okay, 1 and 10 is not going to work, but 2 and 5 will. So we can say we've got a plus 2 and a take 5 equals 0. Right, null factor law again. I can say that a equals negative 2 and a equals negative 5. Okay, so I substitute my value back in here, and you can see though that I actually muck something up here, because we're not going to get nice ones that we can solve without using a log. That's right, that'll be positive 5. Okay, so sorry, 3 to the x equals 5. Okay, so from this, we're going to see this process a little bit later on as well, but from here what we can do is we can say log to the base 3 of negative 2 equals x. Okay, so we do what I call the loopy method. We loop around like this. Okay, and we're going to do the same with this. We loop around. So we say log to the base 3 of 5 equals x. Okay, now for this, so we have a little thing. You are not allowed to take the negative, put a negative value in a log. It doesn't actually work. Okay, so this does not exist. Does not exist. Okay, so therefore this is our solution. Okay, so it was one extra little step there. Okay, there's probably extending here a little bit further than what we need to. Okay, in terms of needing to do this rearranging with our logs. Okay, but this process still holds. Okay, what you need to be doing is looking at putting things, okay, seeing things like this and seeing things like this. Okay, and realizing there's really something squared. Okay, and then doing that process of substitution, or saying let a equal this thing in here to create that quadratic that you're going through and solving. Don't worry too much if you're a bit lost with what I did down here. Okay, that'll make a little bit more sense when we do videos in the future.